polar coordinates. What are they? Up until now in your mathematics career, you have been familiar with coordinates in terms of x and y, which are called rectangular coordinates. And so that's going to be an x value, comma, y value. Here we have, in this section, something called polar coordinates. Now, the things that will tell you that you have polar coordinates are several. One is sometimes the problem will just tell you these are polar coordinates. Another thing you're going to see is that if you have in the second coordinate here a degree symbol, or you have a radian measure symbol when you have a pi or some kind of fraction of pi. So you can have you can use degrees or radians, and that tells you that these are polar coordinates. And one more thing is that you see at the right this set of concentric circles here. This is what is called polar coordinate graphing grid. And we're going to use this for each of these grids here. And polar coordinates have an advantage in several areas. One, instantly for navigation, because instead of having to go over to the right x and up a certain amount for y, what you do is you go in a certain direction first. And this polar graph paper is set up like this. I'm going to draw just like an XY grid right across here. There's my x coordinate, x axis. And here's the y axis I'm drawing here, this vertical line. Okay, so, yeah. Okay, so here we go. We got x and y coordinates. And the way to graph these first is to go counter to what you're used to doing, is take that second coordinate first and go to degrees. Now, one thing you have in a standard coordinate graph such as this one, these are all set at 10-degree increments apart. So that one, first one is 10 degrees. Let me get some finer. So 10 degrees, 20 degrees, 30 degrees. So they're 10 degrees apart. So they'll be all around here. And then over on this other side, you have on the far side, you have 180 degrees, 170 degrees, and 160 degrees. And 160 degrees is what we're interested in. Now, these rings are equidistant apart. And so you can see that the first ring here will be 1, mean radius, 2, 3, 4, 5, 6. So these things here, this 4, for instance, is what's called a radius. And the second coordinate here, which in this case is degrees, is a direction. So we go at 160 degrees first, which gives us to this spoke or this ray here, and then we go 4 units. So 4 rings, 1, 2, 3, 4. So here is the polar coordinate pair graphed 4, 160 degrees. All right, so that's that one. Next, we're going to take I'm going to leave those there, 3, 2, 1. And what I'm going to do instead is we have a radian measure. So in radian measure, we have pi over 3. Now what is pi over 3? Well, pi over 3, if you don't remember what it is, you can convert that to degrees. If you don't remember, by multiplying this by 180 degrees over pi. So pi over pi cancel. So we have is 80 over 180 over 3 equals 60 degrees. So we go to 60 degrees right here, where all these numbers are drawn. And our radius is 5. We can go up 5. Here, I'm going to mark pi over 3 right here. So go up 1, 2, 3, 4, 5. So here's our polar coordinate pair, which is 5, comma, pi over 3. And the last one we're going to look at is this one right here, this -3, comma, 120 degrees. And it's a little bit different. So if we take this, we go to 120 degrees first. Well, up here we have 90 degrees at the top, then 100 degrees, all 10 degrees apart, 110, and 120 degrees is right here. And we have a radius value here. R is equal to -3. Well, what does that mean? Now, if we go to 3, it would be right here. Now, when you have in polar coordinates, you can have a negative radius. And so when you have a negative radius, you go in the opposite direction, opposite the origin. So we're going to go 1, 2, 3. So this is the polar coordinate pair, -3, comma, 120 degrees. So we could see that this is the same as 3, comma, what is that, 300 degrees. I'll just put it here. It's the same as 3, comma, 300 degrees. What we're going to be doing in this class next couple weeks is converting rectangular coordinate pairs into polar coordinates pairs and polar coordinate pairs into rectangular coordinate pairs. It's very easy to do. So anyway, that's just an introductory video lesson. Good luck. Keep after it. Bye.